Chrontsios Garitsis. I am a postdoc associate at the Department of Mathematics. I taught Math 231, which is differential equations, and it is a course for undergraduate students. Is usually during the lecture, I present to students an interactive visualization of certain mathematical topics that I'm discussing in the lecture. I show them how the demonstration works, and I explain the mathematical structure that is underneath. And then the demonstration, the interactive visualization, is accessible to students. Then I split them into groups, and I assign to them problems where they are asked to predict what certain different settings would produce in terms of plots on these interactive visualizations. They are able to predict this with the mathematics behind the plot. And then they have the demonstration. So the next step is to actually perform these changes and see what kind of plots they get. Were they the plots that they predicted, or were they different? If they are different, they discuss first among themselves with their small groups what is different and why. And I help them understand what went wrong with their predictions, or I help them understand why certain things worked a certain way. So it's a really good motivation for them to do the math, since they have a picture and they know what is supposed to happen with this kind of math. Very positively. I saw that after introducing the first demonstration and after we had the first discussion sections where they worked in small groups, I saw that they enjoyed that. And then the next time I introduce a demonstration, I see that they are eager to understand the math behind it and experiment with it and discuss it with their friends in class. And I also saw that in quite a few of the evaluation forums. They really liked that part of the class. Even people who initially might have said things like, math is not exactly for me. I'm not a math person. But that part of the class, they really enjoyed. Something really exciting that happened was I had a couple of students independently come to my office, and they were interested in how these demonstrations actually work in a deeper level. How can they make their own? And that was really nice to see, because I have a math PhD, I'm doing math research, I like math, but it's nice to see people from physics and computer science, in that case, being interested in how they can produce their own such visualizations. And with those two students, we're actually on an undergraduate research project, exactly on creating certain demonstrations on some fractal functions. So, first of all, demonstrations.wolfram.com, it has lots of demonstrations, interactive visualizations already on many different disciplines within STEM and quite a few outside STEM. That would be my first suggestion, to check what is already done there. And they also have access to the source code. But in more general, we are fortunate enough to live in an era where we have access to the internet, and many things are so easily accessible. And if we're thinking of doing something new, there is a good chance that the beginning has already been made. So there are many resources out there that with a quick Google of the sort, literature, interactive, teaching game, you might get things that you did not expect. And you might find things that will really help in this.